Hello, everyone. I'm James Murphy. I am the project lead here for the Swarm project here, and I'm here with Matthew. If you can introduce yourself.
Yeah, I'm Matthew Hubbs. I don't know, what would you call me, the lead on Gazebo, and then I helped with the
Yeah,
object section.
Gazebo, and then we
Yeah,
worked on the object detection. We're going to go through the files here and run the simulation, and then give some tips on if you are happen to be a team that is working on the following project after us, some advice that we might have for you.
yeah. So here's our GitHub. I sincerely hope that you found this if you're watching this video. We have a few different branches here. We obviously don't know what your project is since it doesn't exist yet. But what our project was that we were trying to use Gazebo simulation to simulate a city block and use a swarm of drones to search for BB8 and find him with like object detection. So with that in mind, that's what the project is. This video tour here, that's what we're recording right now. Getting started. If you've worked in Rust before and you know what a package is, this is just a package. We use a few other packages which are listed in the .get modules, so you'll need those as well. Um, if you already know what I just described there, this is easy street for you. Where you don't watching this, just get to work. Otherwise, you're probably on Windows, since most of the civilized world is on Windows. You're going to need to come to the barbarity of Linux. It's not that bad, but everything's a setting. So you're going to need Ubuntu. We're running 20.04. You need specifically 20.04 because all the robot stuff, ROS is Robot Operating System, all of that is specific to versions of Linux. So we're using here. I have a list of so there's ROS 1 and ROS 2. Um, this is ROS 1, I'm pretty sure, and we're using Noetic. Um, and that specifically goes with Focal Fossa, which is Linux 20.04 this year. There also exists ROS 2. We're not using that, so don't worry about it. If you have no idea what the hell ROS is, the Construct is a great site. If you have funding, I would recommend just get a subscription for this site. And James, I didn't tell you this yet, but in the mail today I got the check for reimbursement on that. So
By
just
the way, if you're also watching this and you, like you said, get budgeting, do this as soon as possible. Because just for some reference, we're doing this at the end of our second semester, and this payment was done at the beginning of it. So you can do the time on that, and
couple
that's
months
how
or
long it's
something.
taken to get reimbursements. Yeah.
Yeah. Hopefully, one of the five people on the team like doesn't mind that $45 is missing for like 3 months. For me, it's fine. I know for some people that's like groceries. So make sure you make wise financial decisions. But pretty much just do it and don't worry about when you will get your money back, just not soon. um, anyway, so this is a subscriptions course. It's great. I recommend it. The contract has a bunch of others as well if you're the type who just love, reading tutorials and working through it. It's like an interactive sort of thing where they run Gazebo on like a web client sort of thing, like remotely, and you get to do stuff in browser. If you've seen, what was it, REPL.it, it's like that, but for ROS and Gazebo. Um, so you're going to need Ubuntu 20.04 because of ROS. Um, Virtual machines, it's not going to work. You're welcome to try it. It's great to know what they are and how to use them. So that's great, like professional development if you want to do it. Um, it's not going to work, but maybe you have a supercomputer. Uh, there's links there for that. Dual boot is what we ended up doing. Um, you can follow the information here how to do that. YouTube has a bunch of them. Um, Basically, you put an ISO for the operating system on a thumb drive. You make a partition, and then you flash it to that partition. Um, After that, you're going to, so now you've got Ubuntu up and running. You're going to need to install Gazebo. Follow all this stuff. There's a whole bunch of packages. The most important thing is, like, so you can just run these one by one, or run the script included, and that's this one here, sdsetup.sh. That's the same as what's written here. All these are going to need sudo permissions, or most of them, not all of them. Like change directory won't, but you can run them all with sudo, or you can just run that script. It'll do the same thing, and hopefully I didn't make a mistake, and this will just, plug and play. So after that, you'll have everything set up, and it should have some sort of file structure, sort of like this, where you'll have like in home, you'll have a Catkin workspace, and then in here, you won't have this. Ignore that. But you'll have an SRC here. You'll have, I think you'll have all of these. I'm not entirely sure what is, or no, you'll only have like one gazebo. Yeah, like you'll have like one of these, and it'll be the correct one. This is a little bit messy, but don't worry about it. But basically, you'll have a bunch of packages in this SRC folder, one of which, this here, is our repo that we're looking at on the web here. So that's how that's going to be set up after you finish that. You're also going to need PyTorch and CUDA, which I have open in PyTorch and CUDA. What are these? So YOLO is an object detection framework that uses PyTorch. And object detection loves GPUs and being able to use GPUs. So for CUDA, you're going to download this. There's a video guide in here. This link here. You click on that, and it'll walk you through how to get this. It's much more complicated than in Windows. In Windows, you install like any other program. In Linux, it's a quest for the Holy Grail. PyTorch, whatever version of CUDA you get, you're going to need the matching version of the compute platform. And then and let's say you have like an AMD card or nothing, you can do it on CPU. You just copy this and then you install it on, or you can also use pip instead of conda. There, and then you copy that and run it in the terminal, and that will get you what you need there.
ROCM there, by the way, is the AMD equivalent of NVIDIA. It's just currently in testing. By the time you're watching this, it might be out of beta, but
yeah, if it's out of beta, then awesome. But we can't see the future. Wish we could though.
I can feel it.
Yeah. So maybe this will be out of date, and maybe AMD card people will rejoice everywhere, and you'll have options there. Problems. 3 like big problems that we actually figured out what the problem was and how to fix it. If you get a blue or black screen to death when you're trying to set up your dual boot, you're probably choosing the wrong option on your GPU driver. So like there will be an option for like your first GPU driver if you want to install NVIDIA's, or I guess AMD. I have a NVIDIA card. I don't know how AMD shut out with that. But
you pick safe graphics. If you have AMD, my recommendation is to use safe graphics when you're doing your installation. That makes sense if you follow any guide. Just do the safe graphics.
Yeah. For NVIDIA, you have the open source, which is the same people who made Linux also made that driver for your GPU, and there's one for the proprietary NVIDIA one. So NVIDIA also made a driver for their own GPUs. I don't know what the problem was or which one I picked that didn't work, but when I picked the opposite, it worked, and then I could update to whichever one I actually wanted. So that's how you get through that. If once you actually boot up Gazebo, if your grass texture is looking like a hazard stripe, you most likely don't have, like in your .bashrc, which I can show you real quick. Yeah, so you're gonna be looking for hidden files here. .bashrc here. This file, this is a shell script just like what the SD setup one included in Repo is. But this is special because anytime you open a new terminal, all of this runs. And you'll see, like right here, this is where I was setting up my paths for gazebo models and textures. If you have hazard stripes, you probably don't have that set up correctly. And that's why you're getting like a missing texture sort of thing. If something just refuses to run, then you're probably missing a package. I have a link to like a, sure we'll follow this. Gazebo has, oh actually no, this is just some block. That's not what I was thinking of. But anyway, that's an example of a like a guide sort of thing. But if you're missing package, it'll like fail to actually execute, and then it'll be like a whole bunch of output log. Sift through that, and you're looking for something like missing a package, and then you're gonna install that package. I thought there was another that I thought of for a second, but if it comes to mind, I'll mention it. What was it? Oh yeah, cat can make sometimes. I don't know why, but if you cat can make something and it just fails, try to do it like 4 or 5 more times before you decide to throw in the towel. Because I've had cat can make fail, and I just do it again, and it works just fine. I don't know why, but
the black box scripts, there's not much. You have to do it every time you make changes, as you'll learn in some of the tutorials, like that video when it's explained to Ross. Every time you do every time you make a change that's related to anything model or gazebo related, so not all Python things, usually just like scripts that are going to be maybe tied to the Ross, that's the only time that you need to. But otherwise, you shouldn't have to be doing cat can make. It's only if you're really making gazebo changes. So
yeah, and cat can make is this, like in case you're having a hard time hearing us, it's CATKIN is right here. That's the command. And you also do run that.
You'll do the source devel every single time. It's going to become very repetitive.
Yeah. But like sometimes you'll do cat can make and it'll say like failed to make something. Just run cat can make again. That worked one time and I didn't change anything. I just ran cat can make again. Strange, but it worked. Running a simulation. So we're gonna go into our VS Code here. So here's a launch order. We're gonna pull up a new terminal. And basically what you're going to do here is in each different, you're going to run each of these in its own terminal. So see like here, the last command run was this, and you see this matches that first one. But before we do all of that, we're going to look through the actual files that these are running. So first, ROS launch, and I suppose also ROS run. But it just says we're going to run a file. The second parameter is what package it's going to come out of. So if you remember back in here, Project Swarm, SRC, these are all packages. That's specifying what package to look in. So Project Swarm. If you're curious how it knows like what is the package and what is just a random folder, it's in the CMake list. There's documentation on like a wiki for, I think it's ROS wiki, and it'll explain how that actually works. To this day, I'm not entirely sure how make lists work, but they like keep track of your packages for you. So that's your second parameter, and then you have to specify in that that package, what do you want out of that package. So like ROS launch, if we look this up, this is a launch file. We're going to like run this file. This is XML. It's I think ROS uses special XML something or another. But basically, we're just spawning all the things in the world, and then we're spawning BB8 in as well. Multi-quad rotor 2D is the next one, and that's here. We're spawning 5 UAVs, or sorry, four UAVs.
We'll explain why we didn't choose to go with 5 later on.
Yeah, that's
Your task is to get it up to 5, or for whatever reason, increase it beyond that. Well, 1, you can copy paste a lot of this stuff, but 2, we have things to say in the future.
yeah. But like if you did want a 5th one, you'd be doing copy that and then make it 5 instead. Next one is multi-slam 2D. I think that has something to do with SLAM is simultaneous localization and mapping. This is, I think it's running a like a new node for each of them, and each one gets their own map. So basically, what they're doing is, so lidar, if you don't know already, is a like think about a laser, and like we know the speed of light, so we shoot out a laser, it bounces off of something, and we see it back, and we measure how much time it took that laser to get there and back, and now we know the distance. And so it lets you sort of map a like a plane on a 2D lidar, and you get to know how far from each obstacle you are. It's sort of like echolocation on a map. And what we're doing is we're essentially constructing a map based off of those lidar returns. Next one is MoveBase. MoveBase is a package that I think it does all our pathfinding. It does like if we are at a certain location and we want to move to another location, it does like I don't know if it does A star or Theta star.
It does.
Is it A star?
Yes.
Yeah. And then it'll plot the path for you. I'm gonna skip Beginnerize and Master Detection for a moment. Multi-Explore is what we're doing with, so it's a package. It does frontier exploration. Andrew knows more about that. He's not on the call right now, but you can go into like our final document and our final presentation slides and learn a little bit more on that, on how exactly it does that. And then we've got Beginnerize and Master Detection Pi. Beginnerize, we're doing, this is just threading, and we're doing, we're calling functions that are in Arise. And then they start those functions, they wait for each other to finish, we print, we're done, and that's it. So what are those functions doing? Pretty much the same thing 4 times. So we'll just look at one of them. So what we're doing is we're, this, I don't know if we actually have to do it, but it solved some issues I was having. This gazebo is just not very stable, honestly. I don't know why it worked, but it worked. We're saying, what we're doing is we're defining a twist, and a twist is a kind of message, and messages are used in things called topics. All of this that I'm spouting off, you'll learn more about in this course here. But you know, the 20-second overview is that there are things called topics that are like blackboards, or you can go up to the board and you can write on it, or you can go up to the board and read from it. So what we're doing is we're creating a special kind of message, and then we're going to publish that message to a topic. So we're putting something on the whiteboard, and then sleep just means wait for this amount of time. It's technically has something to do with threads, and we're not actually like pausing the program, we're pausing that thread, but semantics. So in here we're essentially waiting for 1 second and publishing 10 messages to the topic. That shouldn't do anything, but it fixed my problem 1 time, so it's there. And then what we're doing is we're making another twist. We're doing we're specifying linear X, Y, and Z components, and then angular X, Y, and Z components. So linear is like, think of linear displacement, and then angular would be like turning. And you're turning about that axis. For more stuff like this, you can go to the on Rails branch, which I think I mentioned in the README file. So what we're doing is we're publishing to that, and then we're sleeping for a second, and then we're stopping for 2 seconds. You'll notice this is just twist linear.z. This is meters per second. So this is going to go up at 3.0 meters per second for 1 second. So we're going to be 3 meters off the ground. And you'll notice that if we highlight this, we get things that are similar. We have 3.0, there's 3.0, 3.5, 4.0, and 4.5. So they're all just going to be slightly staggered. I think I forgot the most important part. We're publishing to rosspy.publisher to a specific topic, and this topic is read by the robot, and then it tries to achieve that speed. So that's what that one's doing. Master detection. I hope you've taken robot vision or computer vision, because we're essentially running YOLO 5 times we're running one model, and we're taking in camera feeds from all 5 drones. Let's see. So we're doing. Haven't looked at this code in a while. So this is the important part here, where we have a subscriber. And what a subscriber does is it listens. You know how last time we were publishing to command vel? This time we're subscribing to the whiteboard. So instead of putting stuff on the whiteboard, we're reading from the whiteboard. And we're saying that we're expecting to take an image off of this. This image is a kind of message, like how twist was a kind of message. And then every time we get a message, what are we going to do with it? We're going to do this function and also pass that variable. So we'll look at the img callback function. So all 5 of these subscribers, and now realize that we have 5 subscribers, only 4 drones. I get that apparently doesn't make anything bad happen. Subscribing to a non-existent topic doesn't throw any errors, I guess.
Welcome to Gazebo, by the way.
I didn't even know that was in here. We're done with the semester. The project worked. So image callback. What are we doing here? We're getting data. Data, the first argument is always going to be the first one here. It's going to be the message that you got that is causing you to run that callback function. And then we have a second parameter which is specified, like hard-coded 1, 2, 3, 4, and 5. So now we know that if we get an image, we have, on every time there's an image from the camera, we call this this function, and we have access to that image, and also we know which camera it's coming from. Long story short, we do some conversions. If you're familiar with like photo editing or something, you'll understand why you gotta do that. We're using OpenCV for some stuff. This is some Python syntax that if you're not used to Python might throw you off. We're calling a function from this file called run detection. We're passing these parameters and we're returning multiple return values. If you've only ever used something like C or Java, that might be sort of weird. But yeah, you can return multiple values in Python. So from this, we're going to get back found BB8 results in squint BB8. So basically what we're doing is we're offloading it to another function, and then we do stuff based on what we got back. Without going into this, what we're doing is if we think that we found BB8 because the model says that it is BB8, then we're going to publish to a topic that is I don't think we actually have anything listening to that topic, but the plan was to do something if we thought we found him. And then we print like what camera number we found him on, and we also print the confidence which was returned in results. This is weird. There's these things called tensors. You can learn about them yourselves. But we're doing a slice on a tensor to get certain information back. I believe we also draw a rectangle on it by doing a CV2 rectangle. It's sort of rudimentary, but anyway. This is where we actually do the detection. Oh, also one more thing. Back in master detection, we do... that's not it. Device. Model. There it is. This is important here. Torchhub.load. This is how we're getting our... and also here. This is a file path. And it points to... somewhere. SRC...
Points to our weights.
Yeah. I swear it's in here. Oh, no.
Yeah, basically if you follow your
here it is.
installations, it's all going to go into the right places. Yeah. That's our current model. You might be improving upon it. I would recommend it. And as long as it's a torch model, the code doesn't need to be changing much. Unless it's not YOLO v5, then you'd have to choose to load it in a different method.
Yeah. If it's not YOLO v5, a lot of this you're going to have to strip out and replace. James, do you know anything about, are they planning a v6? Or I know they're still supporting v5.
So there's just a little bit of heads up from where things that are developing beyond what we're at. There's a couple more YOLO algorithms. It's not really being called V6. There's YOLO R. There's PP-YOLO. And then there's V2s and V3s for that one. So there's a lot of stuff that's developing off of the name. Whether it's even doing YOLO anymore, and you can do your history on what the original YOLO algorithm is. Who knows anymore? Because a lot of it now is just since it has such a well-known name. You're just going to find people calling it YOLO something. And usually the name is related to whatever technology is being utilized. Because the PP part of YOLO has a meaning for a different method in object detection. And then the R in YOLO R has a different name as well, and they're doing something completely different. So you have to do your research, and it's all down the use case, what you find most useful, and also whatever is going on in the worlds, because what we're using right now might not be the best thing and probably isn't by the time you're watching this. So
yeah, especially if you're a fall semester. We're in spring right now. If we have all of summer and then you're coming back in August, that might be a while. I want to say aren't we doing a YOLO v5s for small?
Yeah, so yeah. When you're just elaborate on that. So when you were at the most of the YOLO models have this, but I know that YOLO v5 specifically has it, is you can choose, basically, you can have more of an option of whether you want speed or if you want precision. So if you want the model to be quicker, it might be a little less accurate, but it's still a very accurate model nonetheless, but it's opting to be faster for detection versus being more confident, so taking a longer calculation to confirm that it's the target. So that's up to you on what your priorities are and what you find to be most useful, but ours was speed, so we went with S, which is the fastest.
Yeah, I think there's S, M, and L for small, medium, and large, and then there's a whole bunch of others, like you already mentioned. One thing to note is this is a variable, and we're passing it into this. So we have one model. You could totally have several different models. Like this is an S1. If you wanted like an L1 to use if you pass a certain threshold, you could totally do that. Well, check your system's RAM. And also, Linux doesn't protect its memory like Windows does. If you cross 100% memory, usage, you're going to start using page files like constantly, and your whole system's going to freeze. I tried that, and I was on a call with James, and then I wasn't on call with James anymore.
Yeah. You can't really tell them go back,
Yeah.
and they can't hear you anymore
Yeah,
because their computer crashed.
I just hard pushed a button and restarted. So this is the function that we're actually calling here. We get the model, we get the cam number, we get the like formatted image. It's called real image because we like changed formats like 3 times from the original format it came in. So we swap some things around. Where do we actually? Here, it's result equals model,
yeah,
and then we pass it in that. This has. I guess we don't have the. There's a like a GitHub page that's a guide on like what format this actually is, but you can see this is how we actually get the confidence out of it. And then back in here, we are returning the result itself as well. Somewhere, return false result, and then yeah. So we do different things with that result to actually get the bounding box and draw it on. It's something in here. It's been so long since I wrote that line of code. I'm not entirely sure what it's doing anymore, but that's where we actually do that. So that's all there is to detection. I'll run this and then close out the video. This has already gotten a little longer than I had expected, but so what I'm gonna do is I'm just gonna, you can right click, you always on top. So now I can click around here, whatever, and that's still on top. Another thing is in one, terminal. If you click here, you'll get a new one. That's how you get these tabs, and it's just like a web browser. Another thing is we've already run this before. If you're typing things in at the terminal and you hit the up arrow, you'll get your last command, and you can go up, more. You get the point. And it will also, I'll pull up Resource Manager, also always on top. Notably, there's no option for looking at GPU usage, but it's not super high. The only thing is using it is object detection and technically graphics on, like you'll actually see in the simulation. Alright, so we're going to do the first one. If we go over to launch order, just left to right in all of these, I have these all queued up. So we're going to launch this one, which is BB8 World. All these errors here are from the last team doing some stuff with like modifying the world file from like an open source something. You'll see this is the world. You can pan around, middle click to left click here, and there's BB8 there. He's hiding behind a mailbox. USPS will keep you safe, buddy. No, it won't. But you can also kick him as described in README. You just totally do it. It's hilarious. This is going to spawn the... We need a better camera angle. This is going to spawn the quadrators. Oh. Tab in. There we go. You saw Arvis flash up here. I have 2 monitors. Let me show you what that was here. This is Arvis. You can toggle through like all the different information a robot is getting. It's useful for debugging. We won't be actually looking at it, but I think Andrew and Sebastian use it a whole lot to debug things. Next up is the SLAM. That's the it gives each of them, like, it starts mapping. This is move base. That's the pathfinding. Let that get good and started. This is the things that'll pop them up that I showed, ran you through the code, and you all go to a slightly different altitude. You'll see like there, you can see it from there, or a little bit askew. Master detection, that's what we ran through. It's going to run all of them. For debugging purposes, you can like make it pop up, but for now, it only pops up anytime it actually detects something, like to display the camera feed. You'll actually see here, you see like one of the camera feeds there in Arvis. You can cycle through all sorts of different stuff. There's like odometry on them. There's LiDAR. There's all sorts of stuff. This doesn't actually show you the YOLO or any YOLO results because that's not running through Arvis. That's running on like our own end. That's our own custom Python, which is why we're having the output pop out here in terminal. And you might have seen print statements earlier. That's here. And this is actually going to make them start moving. Let's see if they actually find them this time. We want to do, play-by-play, and I'll do color commentary.
Yeah, so as you can see, they're going to navigate around. If you read the presentations, they're going to try and find their way around areas that they haven't seen before and they know they can get to. So that is the main thing that it is trying to do right now at the moment. So we can see he's going towards the BB8, but they don't know where the target is. They're just evaluating and making a decision on which way they should navigate to. It might not be right, but it will eventually find it because it will check everything that it hasn't seen before.
I just started a stopwatch just now. I'll give it 2 minutes. It might find them. It might not. Who knows? One thing to note is you can mess with the what you get out, and you'll see here. You're actually getting a confidence score back. Sometimes you get more than one. Like here on cam 1, we saw 2 things we thought were BB8. One with a confidence of 29%, another with 28. Someone just hit 52. Typically, you'll put 50 as your detection threshold. But since we didn't get enough data and our model isn't good enough, like it thinks these car tires are BB8, it thinks that shadow is BB8, it thinks that circle up there is BB8. I never tested it on stoplights. I bet it thinks there's 3 BB8s.
It wasn't because of the colors.
Oh, the colors. I think it's picking up on orange. It had
I highly
62
recommend
up
pick
here.
a better target with more attributes.
It's going on than just a circle.
Yeah. So it looks like one of those 2 might find it. Let's follow you. Oh no, you're coming down there. 3. Yeah, so 3 might find him.
There we go. Yeah.
Maybe. But yeah, you'll notice that we got like 60 something above. Typically, you'll put 50 as like your threshold to actually stop, and call it good. Oh, we hit 74.
There you go.
And here's bugged out a little bit. You'll see this here, like down here. It's not responding.
Oh,
I want to
no.
see. I want to see the
we
image.
found saw there.
Yeah.
That's so. Why did it crash that time? That's really weird.
Did it pop up on my other monitor? Nope.
No, it did a force quit.
Yeah. Oh well. But that means we did actually find them, and we saw. Typically, that'll actually pop up, and it'll show you a picture with BB8 and then a box drawn over it. You can see the demo, like the demo video we have in our README, and it actually does it there.
Might get another detection, see if that one pops it up.
Yeah. I think I said it's a 75. I don't remember.
It was,
72?
I saw that on there.
77? Oh,
There's
we got
another
a second one. Hey, there it
you
is.
go.
Yeah.
Alright, that.
So that's
That
it
one
there.
There we go.
And my phone's at 2:55.
Yeah.
But I started a little late. The project requirement was 3 minutes, but I ran it the first time and we got in 240, 238 or something.
Yeah, it got, obviously, and also the other drone found it earlier than this, but...
Oh, yeah, that's true. But yeah, things we could do is we could make them faster. We discussed different means for exploration besides frontiers. Another thing, I'll just leave this running. One thing to note is, like, you'll see my system resources here. We're pretty much... Oh, I just hit the X. Oops. Oh, no, it's here.
So system resources are basically at max on your CPU. If you
Yeah.
saw, a lot of the things were threads, and for anybody that's done some work with parallel processing and stuff like that, you know how the processes add up, and then you're basically taking up space of the CPU. So before this, it was just running pretty clean. There wasn't any issues, but now we're pretty much close to like 80, 90, and it's almost all the cores are pretty effectively being used.
Yep.
If you add another drone, all that goes up exponentially. So that's why we ended up having an Optwood 4. We had a 3D solution, which we left it there as a feature for you to see, or if you were to continue work on that. If you can navigate to that real fast. And that was basically some work that we did in 3D. It was never finished on because we couldn't run it, but it has some of the work there for you guys to, if you end up working on 3D or want to implement a 3D, your work is there. Now, the one thing that I will say is that we did do research, and you can do a cloud solution if you want to go to the site there.
Yeah,
where that you can basically deploy it and kind of have like a front-end graphical interface with Gazebo on a AWS server, which will suddenly let you just run everything through the network, and then you don't have to worry about or anything about computation. We didn't do it, so we can't really speak for it, but the solution was found, but too far into development for us to implement. A lot of our stuff would go out the door, so you'd probably have to do a lot of conversion, but that would at least let you have something to work with to implement without any issues when it comes to computation. So that would be all that we have to say, I think, right?
Yeah,
Both of our contacts are in the bottom of the repository. If you have any questions about anything or would like to reach out to either of us regarding any questions or any problems you have if you try to run this, feel free to reach out to any of us. We'll try to do our best. Can't promise that things are going to be staying updated, as we're definitely not going to be iterating on it anymore, so it might not age like a fine wine, maybe more like a fine milk, which would be poor. But yeah.
Yeah, so we've got my email, James's email, and then we do have a Discord. If it's still there, all 5 of us are in there. I know that like Sebastian and Andrew did a little bit more on like the 3D solution. They may or may not still be in that server, and that server may or may not still exist. You can try it if you're on Discord. But yeah, I think that's all I've got.
Alrighty. Well, thank you very much.
Good luck, guys.